8.1. We're talking about exponents. The blue paper I gave you that you were to glue into your notebook has all the rules we'll need for this chapter. It is a good reference for you to have at the beginning of your chapter. Let's look at 2a to the n. I need you to understand what your pieces' names are. So we're going to write 2a to the n somewhere in your notes. And we're going to go over them. First of all, does anybody know what the name of any of those pieces are? These all have a name. What's the exponent?
The A.
The A is not the exponent. The N is the exponent. The A is a variable, but in this case we're going to call it a base. What is the 2? It is a number. It begins, the letter of its name is a C. Coefficient. It is a coefficient. Oh, sorry, books all scribbly together, and my pen wasn't right. It's a little bit better. All right, so the first rule is product of powers. What you need to know here is you must have the same bases. And I like to call this side by side, because they're literally sitting side by side. In side by side, you add the exponents. So when they're sitting side by side, a to the m times a to the n, you add the exponents. When they're side by side, you add. We will be doing a separate rule of a power to a power in a little bit. But right now, side by side, you add. All this should be written in your notes. This is what I'm checking for. Kara, get your yellow notes out. That's what we're taking the notes on. Kara, you didn't write down anything I wrote. Kara. All right, let's look inside the box. B to the second, B to the fifth. Do they have the same bases?
Yeah.
They're both B's. They have to have the same base for you to do this. So what would you do with the exponents? You would add the exponents, so you get B to the second plus 5, which will give you B to the 7th. Let's talk about exponents. They have to look like they're exponents. They cannot look like they're beside the number. So if you gave me B7, I would not mark it right. I would mark it wrong. It doesn't look like an exponent. It has to be above the letter. All right, here, it's a little bit bigger problem. 5x squared times 9x cubed. First of all, always check, do we have the same bases? Yeah, we do have. So we know we're going to have an x. We know side by side we add, so 2 plus 3 is 5. But we multiply our coefficients, so 9 times 5 is 45. Okay. Now let's look at A through D. These are easy, simple, easy peasy problems. Let me write something down. All right. Pretty much what exponents do, we're just counting up the amount of the base we have. So here we have bases of 2. So we're going to have a 2. And 2 and 3 sitting side by side. The exponents for 2 and 3. So we add our exponents. So it's going to give us 2 to the 5th. So what that's saying is we have 5 2s. Well, we know that's true because in the first one we had 2. In the second one we had 3. So altogether there are 5 2s. 5 2s. Now what about these W's? We have W to the 9th and W to the 7th.
Then you still add the 9 to the 2.
Right, you add the 9 to 2. says 4 to the 4th and 4. Well, we have these hidden 1 exponents that we don't have to write. That is assumed. Any number or letter by itself is assumed to have an exponent of 1. So this 4 right here has an exponent of 1. Nope, it's always 1. So when we add our exponents, 4 plus 1 give us, so it's 4 to the 5th power. When we look over here, this 6 has an exponent of 1. Negative 6 has an exponent of 1. You need to write them in. You will forget that they're there and you'll get the problem wrong if you do not write them in. So everybody better have them written in your notes. So this gives me a negative 6 in parentheses. But to what power? Power. Yep, because 1 plus 6. And don't get your calculator out and give me some big number. I just want you working on the exponent rule. I want you to know when to add and when to multiply. That's the whole point of it. All right, page 2. This is a power to a power. So what that means is you're going to have a base to some power, and everything is going to be raised to a different power. So A is your base, M is an exponent, that whole thing is raised to another exponent N. This is a power to a power, and here you multiply your exponents. So the answer here is A to the M times N. And M and N are going to be numbers. We also have to watch where our hidden 1s are. We'll find them. All right, inside the box. If you have D to the 5th, all to the 3rd power, you're going to have D to the 5 times 3, which is D to the 15th. So you were right. This 3. What about this 3? There's something unique about that 3. It's a negative, but what exponent does it have? What exponent do we not see? It's there. They don't have it written. The 1. The 1. So that negative 3 has a 1 exponent. And you have to write it. You can't lose it. So this 3 on the outside, this 3 power 3, is going to multiply. So 3 times 1 is 3. And we're going to have an x. 2 times 3 is 6. We're going to have our y, and 4 times 3 is 12. But you can solve negative 3 cubed. It's negative 3 times negative 3 times negative 3. What's this that give you? 9. That will give me 9. What's 3 times 3? 9. Times another 3. 9 times 3. 27. Is it positive or is it negative? Positive. It is negative, Kara. Well, let me show you.
Oh, I see. I did it wrong. Sorry.
So it is give you a negative 27 x to the 6th y to the power. The A through D are a little bit easier. So let's look at those. Here we go. 5 squared to the 3rd power is going to give you 5 to the what? 6. 5 to the 6th. Are you writing this down? Nope, I just want to write it right now. Just want to use the exponent. Don't want some big number. N to the 7th, all to the 2nd power, all squared. All right. Now look, when we're over here, this negative 3 is our base. That's our base. So we just have to multiply what 2 numbers? To get negative 3 to the 15th. And look in letter D. This is D minus 4 thing is my base. So I will have b minus 4, and then 2 times 5 is 10. So those are my answers, guys. Write them all down. Okay, so this is the same rule, only there's going to be 2 different bases inside. If we have A, B, 2 terms, all to the m power, well, if we have our magic 1s up here, then this will be A, 1 times m is m, and B, 1 times m is m. So we're just using the same rule, you're just using multiple variables. So where are my hidden ones in the box where we have x, y, and z? On top of x, y, and z, if they all have a 1. So then you're going to have x, 1 times 3 is 3. A y, a 1 times 3 is 3. And a z, 1 times 3 is 3. And there's that answer. That's all we have. But we also have hidden ones on the 5bc, the third power.
On top of them all.
Yes. On top of them all, there's a hidden one. So you're going to have 5, 1 times 3 is 3. B, 1 times 3 is 3. And C, 1 times 3 is 3. But we can figure out what 5 to the third is. As long as we're not going to get a humongous number. Not 15. Don't take 5 times 3.
5 times 5 times 5.
5 times 5 times 5. What is 5 times 5 times 5? Well, 5 times 5 is 5. And then 5 quarters are. What are 5 quarters? 25. 125 b cubed b. This is my answer. Now, when you look at letter A, you're going to think, I want to get some big thing and multiply 4 times 16 and then take it to the 7th power. We just want to see if you know the exponent rule. That's it. So put your hidden ones over top of the 4 and over top of the 16. I want to see if you can do the rule. That's it. So we'll have 4. 1 times 7 is 7. 16. 1 times 7 is 7. That's what I want to see in the homework. I don't want you to get your calculator out. I don't want big number answers. I only want to see if you know which rule to use and if you can use it correctly. All right, next one. Where are my hidden ones? 3, the r in there. Yep. So we'll have negative 3 to the 2. We'll have r to the 2. And we'll have s to the 2. But we know what negative 3 squared is, don't we? Not negative 6. Positive 9. Because it's negative 3 times negative 3. Negative 3 times a negative 3. Gives you a positive 9. But in letter C, when the negative's on the outside, it just lives on the outside. Put our magic ones in here. Right? Our hidden ones that we have to fill in. And we will get 3 squared, r squared, s squared. And we know what 3 squared is. 3 squared is 9. It'll be negative. This will turn into 9, r squared, s squared.